Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important CSIR question from electromagnetic theory. Already from 2 days back onwards, we are teaching the electromagnetic theory syllabus. Daily one video I am uploading to you. So please share and subscribe and like our YouTube channel. Like these videos we will upload in our YouTube channel. Listen and enjoy. You will get the great knowledge in the physics also. Not only that, once again I am appealing to you, if you really likes my teaching style, if you really likes teaching, so then you go for the app, you purchase the app and you negotiate it also, right? That my mobile number, everything is there. Once you contact me and then you confirm to join or not, you see. Otherwise you have to listen in YouTube channel also. First, what we are discussing today, we are discussing the two classes. One is Coulomb's law, another one is the Gauss law we are discussing in the YouTube. So from Coulomb's law, one question from IIT JAM only I told. From the Gauss law also one question from the IIT JAM only I told. Now today I have to take the CSIR question, that is from the application of the Coulomb's law. So application of the Coulomb's law, what we have to find the electric field. How we have to find the electric field? Once you have to see, when this question was asked by the CSIR people, that in 2012, right? So now you able to see three charges are located on the circumference of a circle of radius. On the circumference of a circle of radius, now you have to see, this is the circle, that what is the circumference of the circle of radius is equal to, that circumference of the circle of radius is equal to capital R, as shown in the figure below. The two charges capital Q, the two charges, the charge 1 you have to take it as a capital Q, and one more charge is capital Q. These two capital Q's are separated by how much degrees? 90 degrees they are separated at the center of the circle. This is the center of the circle you have to take. The charge Q, small q, is symmetrically placed with respect to the charges Q. The charge Q is symmetrically placed with respect to the charges Q. If the electric field at the center of the circle is equal to 0, if the electric field at the center of the circle is equal to 0 electric field is there, what is the magnitude of the charge they are asking? What is the magnitude of the charge they are asking? How we have to find the magnitude of the charge? Now you able to see. First you have to take a test charge at the center. The test charge you have to take it as a positive charge you have to consider. The test charge you able to consider as a positive charge you have to consider. Now you have to see, so there is a repulsion is there and positive, so that electric field direction, what is that electric field direction? That electric field direction E suffix 1 is going in this direction. That electric field direction is E suffix 1 is going in this direction. Now the electric field direction E suffix 2 is going in this direction. E suffix 2 is going in this direction. Based on the Coulomb's law, we have to write, you have to take a repulsion, that is the direction of the electric field is force direction, that force direction is away from that charge. So therefore the resultant charge is equal to what we have to take, this is the E12, that is the resultant of the E1 and 2. Now the due to the charge Q, that you have to take, this is the away from the charge, that electric field direction is E3 you have to take. Now you need to calculate, so what is the E1? So E1 is equal to E2 is equal to 1 by 4 pi epsilon naught into capital Q is divided by R square, that R is capital R is there, so that's why you have to take it as a capital R square we have to write. which is equal to E1 is equal to E2 is equal to, we have to write it as a E. This is the electric field due to what? So, due to the point charges capital Q's, you are getting the same electric field. Now, we need to calculate the E12. E12 is equal to, how we have to calculate by using a parallelogram theorem. E1 square plus E2 square plus E2 E1 E2 cos theta we have to write. So, 2 E1 E2 cos theta is equal to cos 90, theta is equal to 90 degrees, cos 90 is equal to 0, 0 into something is equal to 0, this is the entire thing 0, E1 is equal to E2 is equal to 2, so therefore 2 into root 2 into E, we are getting, that is the E12 value. Clear? So, now we need to calculate the E3. How we have to calculate the E3? Due to the small charge carrier Q, that is 1 by 4 pi epsilon naught into small q is divided by r square, that is the E3. Based on your diagram, E is equal to the net charge at the center, E is equal to the net charge at the center, E is equal to, one more page I have to take to you. So, the net charge at the center, E is equal to, what we have to write, it is E is equal to E12 plus E3. So, but according to your problem, at the center that electric field is equal to 0, therefore E12 is equal to root 2 into E plus E3 is equal to, so what we have to write, it is Q3 into, so that you have to take in the minus direction, you have to take, so Q3, so Q is divided by 4 pi epsilon naught into r square we have to write, because in the negative direction is there. So, that is why you are able to take here minus, you have to write, otherwise you have to consider as a this one. This is E12 minus E3 we have to write, that is the, so correct one you able to get. So, therefore, root 2 into E is equal to, we have to write E is equal to capital Q is divided by 4 pi epsilon naught into r square, which is equal to small q is divided by 4 pi epsilon naught into r square. So, 4 pi epsilon naught, 4 pi epsilon naught, 4 pi epsilon naught, 4 pi epsilon naught, r square get cancelled. The root 2 into capital Q is equal to small q. So, therefore, capital Q is equal to q by root 2, you are getting that. So, this is your answer. So, what is your option? Once you have to see, your option is going to take it as, your option is equal to how much? So, A option is correct, capital Q is equal to q by root 2, root 2q is not correct, and so you have to take it as a 2q is not correct. So, D also 4q is not correct, option A is correct. How simple it is. This question was asked for 3.5 marks. This question belongs to what? This question is belongs to the applications of, this question is belongs to applications of which law? It is Coulomb's law. This question is belongs to applications of Coulomb's law, right? This is very, very important question. So, if you really likes my teaching, I am sending to you daily. We started the CSIR and GATE physics content course in our app. Our app number is Quantum Online Academy. You are go to Play Store of your Android mobile phone. So, then you download my app. After downloading my app, the symbol will be displayed like this. After, so you have to log in into that app, then you display the courses you able to see, CSIR and GATE physics course, and so individual papers also we started, mathematical methods of physics, classical mechanics, and electromagnetic theory. So, these papers already mathematical methods of physics, classical mechanics are completed. Now, electromagnetic theory is going on. This electromagnetic theory is live plus recorded classes are available. If you have to join in CSIR and GATE batch all these days, you may get 2 years validity. Once finish the syllabus, I have to suppress this validity into the 1 year only. So, this is a great opportunity to utilize this opportunity. You listen the live classes, you listen the recorded classes up to the 2 years. Whenever you will be free, that time you have to listen. Thank you so much. So, please share and subscribe our YouTube channel and inform to your friends within the physics fraternity. Thank you.